Hi, everyone, and welcome to this session on Microfrontends Antipatterns. Today, I want to share with you my journey on Microfrontends, but moreover, my learnings on the last 7 years building solutions that are based on this architecture. I created a global solution that was running on multiple devices, including low-end devices like set-top box and consoles. And also, nowadays, I'm in AWS, I'm helping our customers to design properly their Microfrontends architecture. So this is a session that I really wanted to do mainly for providing the experience that is difficult to find in the industry because it's a brand new architecture and there aren't many people that are fostering for several years. My name is Luca Mezzalira. I'm a principal solution architect in AWS. I'm an international speaker and an O'Reilly author. So let's start the journey when, for the first time, I have seen Microfrontends. Back in the days in 2015, it wasn't called Microfrontends, it was called micro-apps. And the first implementation I have seen was during a conference where a couple of Zalando engineers were sharing their implementation of Microfrontends and they open source Tailor.js. Tailor.js was a composition layer for Microfrontends, for creating server-side rendering Microfrontends. And it was one part of a larger system, as you can see in this diagram, that basically was assembling multiple HTML fragments and returning to the final view to the user. The great thing of this approach was the first implementation at scale that I have seen in a company like Zalando. In 2016, the things are becoming more official. In fact, we see for the first time the name Microfrontends in the technology radar from ThoughtWorks. If you're not familiar with the technology radar, is one of the tools that you can read and is provided open source by ThoughtWorks, and you can see what they are trying, what they are assessing, what is a technology that they see working with their customers. And Microfrontends, back in November 2016, it was to the assess stage. In 2019, we started to have an adoption of Microfrontends. Early adopters were different. There were companies like Spotify, Starbucks, IKEA, and many others. I tried to summarize in this tweet few of the big companies that I have seen back in the days working with Microfrontends. Obviously, from 2016 to 2019, many companies that they were trying to create Microfrontends architecture and trying to understand how to apply at scale this concept. But as you can imagine, there were many companies and a lot of knowledge around that. In 2020, we finally start to see Microfrontends as a trend. And in fact, InfoQ in their architecture and design report, they put Microfrontends in the innovators part of the bell curve. It's very interesting because as you can see now in recent years, you will see the Microfrontends now are at the early adopter stage. And that's great because it means that more and more organizations are implementing this architecture pattern and it is extremely interesting. 2021, I call the discover year. We started to have a strong adoption of Microfrontends. Companies like PayPal or American Express are leveraging this architectural pattern, but there are many others. And the interesting part is that now that there is a strong adoption, it means that we are going to learn a lot. We are going to learn what it works, what it doesn't work, and that's also the purpose of this talk. So just to summarize, the Microfrontends benefit that we have seen so far is that definitely you can have incremental upgrades. So you can develop a portion of your front-end application, deploy in production, and start to gain value out of it. And also gather information on how the things are working, if your CI/CD is working properly, if it's fast enough, how your code is working, if there are benefits compared to the legacy application. So there is a lot of value on that. We understood that Microfrontends leverage the concept of company decentralization or organization decentralization. What it means is basically you are creating some boundaries as a tech leadership for having the teams striving inside them. So you maybe define what is the tool for defining the CI, or what are the languages that the teams can use. But in reality, then the teams will be in charge of running the show. They need to build the code. They need to, write the code, to build the code, and also run in production and maintain it. And that's a great novel way for front-end developers to handle this, because at scale is something that often we haven't seen applied properly. So the concept of DevOps, the concept of what we have experienced so far with microservices, so it's applicable also with micro-frontends in the front-end world. The other cool thing of microfrontends is that there is a reduction of cognitive load. So the team doesn't have to know everything inside out of the application. They just need to have to know very well their portion, their domain, as is called. We know that microfrontends basically is assigned to a specific team, and the team should master that code. And that is great, because it means that you don't have, in a large organization or large or complex application, know everything. You just need to know your part very well and being able to support that code base properly. And finally, another benefit that we have seen is that the microfrontends approach is not only a technology solution, it's also an organizational one. The fact that you can break apart in a distributed fashion your application, it allows you to spin up new teams very quickly, and also to create some team that can work independently and work faster, because they don't have to coordinate every time with the tech leader that is maybe based in another office or in another country, in another time zone. And that's great, because it means that you have autonomy and people can move faster. One thing that I really like since when I joined in AWS is this sentence from our CEO. There is no compression algorithm for experience. And that's so true. And what I want to do today is leveraging this concept of experience and trying to compress instead my experience in 30 minutes, so you can understand what you could do and what you couldn't do with microfrontends, best practices basically. So let's start with the first anti-pattern, as I call it. I call it the yin and yang, or the difference between microfrontends and components. Those two things are not mutual exclusive. You can have them working together very well, but you need to understand which one is which. Let's start from the beginning. So usually imagine that you have something very simple, like a button. And in this button, we create and we want to have a label. Perfect. So we generate our component that is a button that has the possibility to set a label. And then there is a new requirement coming. You want also to have an icon. And this icon could be different. And it could be that you might want the icon, you want to hide the icon if I don't pass a parameter for that. But there are several options there. And then a new requirement comes in, and you want to change the border color of the button. So a new property has to be exposed to this button. And then you want to have a different rollover animation, because this button, for a specific portal that you are developing, has to have a different rollover animation. And then you are introducing localization, and therefore you want to have an outer size of the button. And finally, you want to have a new feature, because after a while that you're using this button, you discover that there is use in a form, but it has to be disabled by default till let's say, the user fill all the fields inside the form. So as you can see here, there are a few things that are implemented in the button, but driven by someone else. So the container of the button. So the context of the button is driving the component. If we look at the microfrontends instead, we are talking about a technical representation of a business subdomain. Usually a button, it doesn't represent a subdomain. It's more a technical solution. It allows independent implementation with same or different technology. And usually we minimize the code share across subdomains, and the ownership is only one team. So if we focus on the two key characteristics of a microfrontend, so technical representation of a business subdomain and independent implementation, we immediately see that a button, or in this case, this component, it doesn't fit inside the definition. And what it means is we are in front of a component that is extensible, and in this case, the container or the context is driving how the component is behaving. And that's the key difference between microfrontends and components. So in a microfrontend, instead, what we would have is independency. So a microfrontend knows how to behave inside out. It doesn't mean that we are not passing certain information from the context that is behaving, but those are limited, are really, really small. So for instance, we could pass an ID for saying this is the ID of the element that you need to render, and the microfrontend knows which API to call, it knows how to behave, how to render itself, and so on and so forth. Another thing is domain aware. So he knows exactly what he has to do. It doesn't have to someone else or the context to provide all those information to behave in a certain way. And that allows to, and is tightly coupled with the concept of independent deployment, because now we can deploy our microfrontend independently. We don't have to coordinate the deployment across multiple teams. A microfrontend defines its input and output. So we know usually if we have a microfrontend working alongside other microfrontends in the same view, what events is looking for and what events is triggering or emitting. And that is great because that means we can independently stitch together multiple microfrontends without the need of coordinating too much with other teams. And when we want to, for instance, redeploy a microfrontend, we don't have to coordinate with other teams as long the events that are in input and output are not changing. And if we add a new event, it's not going to change the result for the other microfrontends living in the same view. So that's great because it's let's say building up on the concept of independence. And finally, it's not extensible. We are not moving or controlling the microfrontend from the context. The microfrontend is a self-contained solution, and that's exactly what we are looking for with microfrontends. So when you start to have an implementation of microfrontends that contains a very granular approach where you have the header, the footer, you have the image that are all microfrontends, probably they are not microfrontends. Probably you're talking about components that you want to lazy load. That is a different kind of solution. So we need really to understand that when we have components or when we are dealing with microfrontends, that's the first key thing. Second anti-pattern I have seen so far is the Hydra of Lerna or the multi-frameworks approach. That is one thing that I read several times over and over on socials. We use microfrontends because we want to use multiple frameworks. Now, the question for me is, how often you have seen multiple frameworks in a single page application? Probably the answer is none or not that often. The reason behind our performances, right? So we know that using multiple UI frameworks in the same single page application could cause more than one problem. That is also true with microfrontends. We don't have to penalize our users because we are using a specific architecture, in this case, a distributed architecture. That is true. You can do that, but you don't have to. And the interesting thing is that there are certain situations where a multi-framework approach makes sense. For instance, when you're dealing with legacy systems, we said before that we create independent artifacts with microfrontends, and therefore you want to iteratively test your assumption and your code in production as soon as possible. What you could do potentially is slowly but steady replacing a legacy system instead of going in stealth mode for 12 months and then suddenly you do a big bang deployment replacing the old application. You can take a portion, a domain of your application, building your microfrontends, deploying production, and start to learn from that. So in that case, you could end up having a legacy system living alongside the microfrontends system. And therefore, it means that you can have multiple frameworks working together. Another solution is when we are migrating from a UI framework to another one. So for instance, imagine you're using an old version of Angular and you want to migrate to the new one. So once again, you can iteratively replace portion of the application and then slowly but steady migrating the entire application to a new version of Angular. And finally, when there are acquisition of new companies and you want to immediately have, or as soon as possible, have value from that acquisition, you can work alongside multiple applications inside under the same umbrella, so under the same website. The third anti-pattern is the Swiss Army knife, or trying to write programs that do one thing and only that. And that is the Unix philosophy, right? So we are very used to that kind of thing. So imagine for this anti-pattern to have a greenfield project. It's a micro-frontend one, so you spend a month on analyzing and understanding how the things are working. So in this case, you have your micro-frontend that is loaded in one go. Then you have another portion of domain that you have multiple micro-frontends to view. So you can mix and match those kind of approaches. And then you said, okay, perfect. So if I want to communicate between micro-frontends in the same view, I'm using an event emitter. And when I have to communicate between views, I'm using the web storage, so local storage or session storage. And for loading and composing basically my microfrontends, I'm using System.js. That's all great, but suddenly a new requirement comes in. This new requirement is a legacy editor. The team is not available anymore in your company. There is just one person that has to integrate and maintain this legacy editor. Now you want to integrate this inside your new application because writing from scratch the legacy editor would take months, and therefore you couldn't afford that. So suddenly you have this legacy editor that is written with a different technology and maybe has different way to communicate with the external world that doesn't fit inside your architecture. So you need to maybe create what is called an anti-corruption layer between your application, so your microfrontends application, and the legacy editor. The beauty of this pattern is that basically you are creating a layer between your new architecture and the old world, and the translation is happening at the anti-corruption layer. So imagine that, for instance, in this case, you could have the legacy editor that is wrapped inside an iframe. And for communicating between the iframe and your application, you use post message. Now, the interesting bit of that is that if you have an application shell that is containing your microfrontends and you're using event emitter or other patterns for communicating, then the post message, it would be an additional one that you need to build in the application shell. Or you can create an anti-corruption layer that is a sort of microfrontends that contain the iframe, and the communication is sanitized between your container of the legacy editor and the application shell. So the application shell continue to work exactly in the same way like it is a normal microfrontend. And the translation between the communication of the post message from the iframe to the external world is done by the anti-corruption layer or the microfrontend container. This is great because that means in the future, when you're going to replace the legacy editor, you don't have to delete code on the other parts, or you don't have to change the way other system or other microfrontends are communicating with an old system. And that's, let's say, another way to overcome a possible complication that you're going to have in the future. We all know that you can start with, oh yeah, this is just this portion, but later on, further down the line, 6 months time, maybe you have 3 or 4 occurrence of this problem. So having an anti-corruption layer could help. Another problem is that dependencies help. I heard several times, Microfrontends is a dependency cell. Oh, wow, what can we do? So my question is, do we really need that external dependency? That's the reality. So imagine this situation. We started to work with Microfrontends and we see a lot of part that could be wrapped in what is called the core library. How many of you work with the core library? So suddenly you have this core library and you have the version 1.1, that is the first one that is going to be in production and is implemented nicely by all the Microfrontends. But suddenly you need the 1.2 version. And the 1.2 version, the team responsible for the microfrontend A can immediately work with it and can immediately implement it. But all the others are a bit slow because the backlog is pretty huge and they cannot take more work on board. So in that case, you need to realize if you can live with this situation, and therefore it's not a big deal, or you must have all the microfrontends using the same thing. And that makes a lot of difference, trust me, because now we are bumping up a version in the minor sense, so we don't have breaking changes. But when there is a breaking change in a library, that could be disrupting because you need to coordinate multiple teams, maybe across different time zones, maybe across different offices, and it's not going to be an easy task. There is another pattern that I have seen that is called the diamond anti-patterns, pretty fun. When you start to say the core team responsible for the core library is too slow, they cannot take into account the specific thing that are needed for different microfrontends. So the team responsible for the microfrontend B are creating the core library extended. That is basically taking some part of the core library, rewriting others, and so on and so forth. So now we have a fork, if you want, or an extension of the core library that is breaking some stuff. So now you have the core library 1.1 that is working perfectly and nicely with microfrontend A and C, and also with the core library extended. But when you start to have a new version of the library, 2.1, and therefore there is a breaking change, this is a major update, what can you do with the core library extended? You start to diverge. And diversion, it could be a big problem, because in the long run, you will see that the core library extended, suddenly it's a different library. It doesn't have nothing to do with the core library, original core library. And you will spend more time trying to figure out if you can squeeze in your core library, new core library extended, the new version of core library, or not. So the problem scales with the number of shared libraries. So if you have just one, okay, maybe somehow you can handle it. If you have 10s of them, good luck, because it's going to be a nightmare. So the reality for me is trying to understand if you really need this kind of core libraries. And if you really need, and there are situations like a design system, for instance, is definitely needed. Having a library that is shared is great, but then trying to work with composition more than extension, and also trying to keep very separated certain libraries and not do a library for everything, because definitely you are going to have more problems. And more teams that are working in a shared library, then they need to test everything is working properly. At some point, you might save some time on writing the code in a shared way, but then you are going to have a lot of testing, manual testing, end-to-end testing, and everything that is happening everywhere. So bear that in mind when you are sharing some stuff in a distributed system. Another anti-pattern is the return ticket, please, or the unidirectional data flow. I have seen in many frameworks that you can have the possibility to have a container or a host that is communicating with the remote. So he's basically embedding the remote inside the container. And then you can do also share on the other side. So you can have a host that is sharing a portion of itself with the remote. Okay, now these can be very complicated. It could happen just once, and once again, happy days, it's just once, so it's not a problem. But when it happens across the entire application, remember that you're working with the distributed system. It can be complicated to maintain, especially in the long run. What we have learned in the past, I would say 15 years in the front-end community, is that quite a few years ago, we had this concept of unidirectional data flow. And that was introduced by Flux. That was a framework or state management created by Facebook that changed completely the way how we were implementing the communication between UI and the data model. Before, it was bidirectional. You could have controllers. You can have, I don't know, other kind of construct that could be bidirectional, but in this case you're going to have this structure that is instead unidirectional. And the same thing, and the beauty of this is that obviously it's very easy to debug. So I know exactly when I dispatch an action and dispatcher take, update the store, update the view, done. And you cannot do it any other way. That's the way how it works. Same thing was introduced in the model view intent architecture, MVI, that is available in JavaScript. There is a famous library called Cycle.js, and now is also used extensively in the Android development, native development, where you have a user that is triggering an action, then we capture the action in the intent, we change the model, or we pass the model the information that is needed for changing, then we load the new state, and the view is updating in the UI. And that's great, because that basically, once again, we can handle very quickly the whole flow of data. Absolutely great and easy to understand. Now, what we learn with unidirectional data flow is, first of all, easy to debug. If we go on the first example that I showed you, where you have a bidirectional sharing or communication, it can be complicated, especially because we are sharing across multiple elements and everyone can share everything to everyone. Is going to be a nightmare. And also it's less prone to errors because I know exactly how the things are working. I know that there is unidirectional, so I can nail the error way faster, especially in production. The other thing is, the other anti-pattern is relax. It's just code. Oh, yes. Now we start to talk about architecture and organizational coupling. So I have discussed several times this anti-pattern. Many people are saying, okay, I have microfrontends. I create a global state with all the microfrontends in my same view, so everyone can use that. I can share content. I don't have to bubble events across the application. That's true. But at the same time, it means that you are coupling in this case, 4 different teams. Because it's not just technology choice. This is also a team choice. The fact that you have a microfrontend A that share the global state with microfrontend C and D and B, it means also that when someone is changing the global state and maybe is changing the type of object that you're storing, the structure, the signature, wherever, it means that everyone has to be aware. You need to coordinate across the teams. So basically you're losing the benefit of microfrontend. So this independence that you are looking for every single microfrontend. A way to solve it is using instead events or a publish and subscribe pattern. Could be events, it could be event emitter, it could be custom events, it could be a reactive string. Doesn't matter. The thing is, everything that could work in a pub sub pattern is definitely your friend in this case. In this case, what happens is that you are defining input and output of the microfrontends. You are defining the microfrontend A is dispatching an event, and whoever is interested, he will listen. So if tomorrow microfrontend C wants to listen to a new event for adding a new feature that maybe is already there, but they didn't care about that event, they can do without coordinating with anyone. They know the microfrontend A is dispatching that event. They just listen to it and start to implement the code. Similar situation if you add a new team that wants to, let's say, listen to multiple events. They don't have to coordinate. They'll read on the wiki or on the documentation what are the events bubbling in that view, and then suddenly they can start to work on this. Great. That's exactly what you want to achieve with microfrontends. Then we have let's hammer the APIs. That's a very funny one. So we have to, there are situations, and I have experienced a couple of times where you have multiple microfrontends calling the same endpoints. That per se, it might seem okay, but then you need to understand the cascade effect. So imagine here that you have those 2 microfrontends at the bottom that are calling API 1. The first question for me is, do we really need to split them up in 2 different microfrontends? Because first of all, we know that we have 2 round trips of the identical API that is going towards the server. So you are slowing down a bit the rendering, but that's, let's say, less than a problem. The reality is, what happens if you have 2 or more microfrontends doing so? Imagine that you are using in the backend a distributed system, so microservices. So you probably have an API gateway that is exposing your API. So then the microfrontends are calling the API gateway. The API gateway absorbs this request and authorize the request. So make sure that the user is entitled to see some content. Obviously, it might or might not be there, the authorization service, because you are handling different ways, but in this example, let's assume that. So now the authorization service has to scale for twice the traffic because there are 2 calls every time. Then you call finally your microfrontend, your microservice, that is the API 1. But because it's a distributed system, the API 1 relies on other APIs. So now suddenly, instead of having one request that is going to the API 1 and all the other APIs that the microservice API 1 is calling, they need to scale for double the traffic. And if there are small numbers, it might not be a problem. If there are huge numbers, it's there that there are some problems. It's not only the complexity and the cost on having something like that. It's also the fact that you need to scale the entire flow. And yes, there are ways to mitigate with different levels of cache or different way to structure your code. However, it's not going to be easy. Therefore, be careful when you do this kind of integration. A possible solution for that is going back to the whiteboard. So you really need to have two microfrontends, or you can have one microfrontend only that is assigned to one team and is handling one request per time. Yes, a bit of more scope on the UI, but probably there are high chances that that specific call or that specific API is inside the same domain. Otherwise, probably you need to go back to the whiteboard and review how your APIs are working. The other option is creating a container that is handling one request and having two components instead of microfrontends that are potentially developed by different teams, but in reality, they are relying on the fact that there is an external container that is handling the request. So you handle just once, and then you have multiple components that are composing that specific part of the view. And those are possible solutions on how to handle these challenge. Now, this was the last pattern, but one thing that you need to bear in mind is that we are at the beginning of this journey with microfrontends, and still there is a lot to learn. Those are things that I have seen and suggest to different customers and different organizations, and I've seen them working. But architecture is always a trade-off. There isn't right or wrong. There are just what it works for your context. Therefore, it's very, very important that when you take one direction or another one, you evaluate what you are gaining, what you are losing for the specific decision that you're making. And it's extremely important because sometimes you might realize that something that is working perfectly in a context in another company won't work in for several reasons. It could be organization structure that is different. It could be the implementation details that are different. It could be the architectural characteristics that are different. So it's very, very important that you are aware of your context before you take a decision. That's all I had got today. Thank you very much for listening. I hope that you enjoyed the session. Feel free to reach me out for any question if you have any, and enjoy the rest of the conference.
So I see two here in the chat, one about the duplicated API calls, and then another one about micro-frontend tooling recommendations. Luca, which one do you want to tackle first?
Let's start from Alessandro's question. So the first question seems to a question around duplicated API code. So the last anti-pattern that I presented. So what if we're going to have a global service that calls the APIs and contain the logic to prevent duplicated codes? Alessandro, definitely you could think to implement that. Let's say the trade-off in this case is that you have to create an API that has to handle the throughput of multiple calls. And especially when you go to the millions, it's going to be a challenge. And then moreover, you need also to handle the cacheability of the request. So if there are two services calling the same thing, you are now creating a service, paying for the infrastructure, and also maintaining the logic in the long run for all these services. And when instead you could fix the problem on the architecture part. And in that case, you don't have to maintain additional code, because we know code is liability. You don't have to pay additional money on the backend or any cloud service that you're using, and you don't have to create a cache layer that when you need to have let's say stale data there for over a certain period of time, you need to have also a logic for invalidating the cache and so on and so forth. So as you can see, technically you can do it. Yes, of course you can. But the drawback are the ones that I listed here.
Okay, the next one, thank you for the answer. The next one was about micro and front-end tooling recommendations. Is there anything specific there for tooling? It seems kind of hard because, you've got, whatever mixture of frameworks on your page. So how do you get any tooling there?
In reality, specific tools for microfrontends I don't think there is any. I think that you can use almost any tool that might suit your use case. What I've seen most majority of the time are companies embracing this architecture, that they are creating their own internal tools if needed. I can suggest a couple of things that I found useful working with Microfrontends. For instance, I know that there is a company called Bit that created a tool for visualizing the dependencies across different microfrontends and different systems in general. It can be used with microfrontends. It can be used with also single-page application. That doesn't matter much, but that is one of them. I think that for all the rest, the usual suspects. So if you use for checking performances, Lighthouse to understand how the things are going, Chrome DevTools as usual. But on top of my head right now, I cannot recall any specific tool that I would say this is a tool that you use only with Microfrontends.
Okay, thank you. Let me see. Here's another question. Do you have any sort of idea of how many companies out there actually use micro-frontend? So if I go to Amazon.com, do you think that's a micro-frontend, or so what's the adoption out there in the industry?
Yeah, the adoption is increasing, I would say, compared few years ago when it started. There is more awareness and more companies wants to leverage the benefits of building microfrontends. So the independence between teams, the fact that they can de-risk the deployment because they deploy just a small chunk of the project iteratively. There is less coordination. But usually my experience are enterprise organizations or companies that have SaaS products. I didn't see many agencies, if you want, that they are embracing this approach, because obviously at some point the agency should provide, let's say, the tool to the company, and therefore let's say the way how they are structuring the code, the way how you need to be you're affecting the code internal culture might be quite disrupting. Instead, if it's an internal company that is building a product and knows that they need to let's say maintain for a long time, or if you are an enterprise customer, definitely there are more companies embracing that. An example that I think is very well known is PayPal. PayPal is using Microfrontends. Also, American Express is using Microfrontends. The American Express is even contributed in the community. They created Holocron, that is a framework for server-side rendering Microfrontends. And instead, PayPal already shared 1 or 2 talks on how they're implementing specific parts of Microfrontends.
Okay, thank you. So we just got another question in the chat here. Do you see any advantages or issues between server-side rendering and SPA-style pages for micro-frontends?
I think similar to what you would do with a non-distributed architecture, right? So you're using server-side rendering when you want to have great control on time to interactive. You want to have a better optimization for SEO, and you want to have, let's say, provide, let's say, a better experience for low-end devices, especially when you work on, let's say, countries where the networking system is not as great as it could be in another country like US, for instance, that is probably one of the greatest for infrastructure. Those are the free for server-side rendering. On single-page application, if you want to have a cohesive experience, you can provide something like that. A more immersive experience, you can use definitely single-page application. But I didn't see many differences of way to tackle a project. If you think about distributed system or not, those remain similar.
So it's really you still put the applications together the same. It's just, whether they contain an SPA or an SSR. Yeah. Really, that's you don't really notice that on the outside. That's why you're running your little black box, and it's up to you what you put into that box. Right?
In theory, it should be like that. Then obviously, the practice is another thing.
Okay, here's another good question. When breaking an abstract monolith, how do you make sure there is no duplication as you move towards micro frontend? So starting with the big ball of mud and breaking it apart. Your experience is that?
I don't think duplication is a problem in general. I would say it's important to reduce that, but you are optimizing for something different with microfrontends. You're optimizing for independency and speed of delivery. If that means that the first iteration you will have duplicated code, it's fine. You are going to reassess later on. There are great companies that have make these as a mantra for how they develop their project. Classic example, Amazon, they discussed the two pizza team approach several times. There is duplication. They accept that because they are moving faster with this approach. And then they reassess if there is some let's say reusability that could happen across different systems, but it doesn't have to be an obsession going straight away in optimization of your code, because when you have let's say global optimization of code and high reusability, you start to have external dependencies that basically is going against the fact to handle distributed system independently, because now you have to coordinate with multiple teams across, let's say, a more complex environment, and more touching points you have, and more effort you will have for coordinating the teams across boundaries.
So it really sounds like there, number one, there is really no avoiding of duplication, but number two, that's not a bad thing, right? Because the trade-off of duplication is independence for the teams, and that's really what you're shooting for, right? You want everybody to be on their own schedule, and if that means some people have the same library or the same style sheet, well, so be it.
Yeah.
Okay. So we had another question about duplication, and so I think we covered it already. So here the last question in the chat: when do you think it's actually worth considering switching to micro-frontends? So do you do that from the start, or is that like an acquired taste that you have to feel a certain pain to move towards micro-frontends?
I would answer in the same way that I would answer a question when to migrate to microservices. I believe that so what you are looking for is modularity. So when you are embracing distributed system, you are looking for modularity. Then you can achieve modularity in different ways. It could be at the code level, it could be at the infrastructure level, or it can be, in the case of microfrontends, even the architecture level, right? So the modularity, it's up to you to decide if it's pertinent at the beginning. Maybe you are like a large organization and you want to start a greenfield project, and therefore you want to start in that way because you already have multiple teams to coordinate with, and you want to maintain independence since day one. But more often, what I've seen is that there are, let's say, companies that wants to validate their business idea. Imagine a startup that wants to understand if what the idea that they had is not baked only by the VCs, but also by the users. So in that case, you need to move fast. And I think microfrontends could be something that could come later when you are in a stage that you want to refactor. Because the problem is not building the code inside the microfrontend, is the whole ecosystem behind it that might be challenging. Like for microservices, the CI/CD part is essential. The fact that you have a unique logging system, a fast turnaround on understanding where the problem is when it's in production, stuff like that are, let's say, challenges that are not simple to solve, but at the same time are essential for distributed systems. The observability part on single page application is usually less let's say essential, like it could be in a distributed system. Is definitely important, but you are not as granular usually as you would be with microfrontends. And instead in microfrontends, because you have multiple teams that are contributing to the same system, it might be a problem if you don't have visibility of the system and why and how it's broken in production.
Okay, thank you. Here's an interesting question. If the microfrontends are in different pages, is this still considered a microfrontend, or do they by definition have to be coexisting on the same page, the same browser page that the user sees?
The granularity of a microfrontend is not defined on purpose. So if you think about microservices as well, it's the same thing. how micro is a microservice, and the same how micro is a micro-frontend. So the reality, what you're looking for is something different. You're looking from the business perspective. So what is your business entity? And remember, don't be afraid to go too much coarse grain. It could happen at the beginning that you decide to take, let's say, a larger portion of the micro-frontend, and it's fine. You're always on time to move from a coarse grain to a fine grain implementation. That's not a problem. The other way around, though, is not true. So if you go to coarse grain, to fine grain, it's way more difficult than sanitize and rebuild something larger. My suggestion, as I described in my book, is always starting from domain-driven design. So how usually you approach a problem. So you start from defining what are the subdomains, and then you start to understand inside those subdomains how many teams are working there and how complex is the subdomain, and then you start to assign those things to the teams. But it's very important that you don't start from a technical perspective like you would do with components, but you start from a business point of view, where you start to understand how the context works, what are the different parts, how they communicate together, and those will basically surface, the size of the micro-frontends will surface to you automatically if you want, because you will start to see them from a different perspective, different angle, more than a technical one.
Okay. Well, thank you. Unfortunately, that's all the time we have in the QA. If you want to ask more questions, then you can join Luca in the Zoom Hangout, and the link is on the schedule page. So I think we'll continue here with the next presentation shortly. If you've got more questions about Microfrontend, please go back to the schedule page, and then you find the link for the Hangout with Luca.
Thank you very much.